Everyone, today we are going to start our new lesson, lesson number 3, and it's about symbols and formula. Okay, we will in today's lecture we are going to learn. We are going to discuss that how we write symbols of elements and how do we write formula of molecules or compounds. Okay. In today's lecture we are going to discuss these issues. Okay, now starting from the symbols. Okay, symbols, why symbols are given to elements. Okay, the first purpose for giving symbols to elements is that in order to memorize elements and learn them easily and fastly. Okay, the second purpose of symbols for elements is that it helps us to understand any chemical reaction. Okay, for writing chemical reaction we usually use symbols. It helps us in writing chemical reaction, okay, or chemical equations more specifically. Okay, for example, if I want to write the formation of water, then if I do not use symbol, what will I write? I will write hydrogen combines with oxygen gas, and a result water will form. So here we do not know that how much molecules of oxygen have reacted with how much molecules of oxygen. As a result, how much molecules of water are formed. So in order to know the number or the amount of reactants and products as well, we usually use symbols. So the basic purpose of symbols is also to understand the amount of reactants as well as products. Here, for example, hydrogen, one molecule of hydrogen, water. Okay, so this is the formation of water. Now here we can easily understand that two molecules of hydrogen react with one molecule of oxygen. As a result, two molecules of water is found. Okay, after balancing the equation. So we can, in simple word, we can easily balance the equation if we use the symbols. Is that clear? So this is the purpose of symbol. Number one is that we can easily learn and memorize the elements, their properties. We can know the amount of the reactants and products, and after all we can also balance the equation. Okay, so this after these symbols, they are being many Latin words are being used most of the time. Okay, capital letters are being used. Sorry. So for example, for calcium, okay, I use Ca. Okay, in the same way nitrogen, N is used. Okay, so the first letter of elements name is being used. Okay, and that first letter should be a capital. Keep in mind that whenever we are using the symbols of elements, we should use the capital letter. For example, nitrogen, for example, oxygen, O capital. Okay, then let's suppose sulfur, S. Okay, let's suppose for example fluorine, F. Okay, sometimes what happens that we also use second letter. Okay, we also use second letter, and this second letter should be used as small letter. Okay, why we use this letter? For example, if there are two elements that starts from same capital letter, like for example sulfur and silicon. Now here both the elements, they are being the initial letter, the first letter is S. Okay, so in order to differentiate these two elements, what shall I do? I will use the second letter. The second letter must be small letter. I will use the second letter in order to differentiate between the sulfur and silicon. Is that clear? Another example related to this point is, let me give another example. For example, carbon. We have carbon and we have calcium. Now here again, carbon symbol is C, calcium is Ca. Okay. Then for example, magnesium and manganese. Both are metals. Okay. So here manganese, magnesium Mg and manganese is Mn. Okay. So second letter is also sometimes being used in order to differentiate between elements. This is the second point. Okay. Now coming towards the third way or third rule for writing the symbols. Most of the time, third point, most of the time Greek names, okay, Greek names for elements are also being used. Okay. The Greek names are also being used for giving symbols. Okay. For example, for sodium, this is English name and its Greek name is natrium. Okay. So here S is not the symbol of sodium. What is Na? We will use the word Na. In the same for example, potassium. Potassium, which is English word. Okay. Its symbol is K. Why K? Because the K is taken from the Greek word, that is kalium. Is that clear? So this is how we sometimes Greek names or Latin names. Okay. Latin names are also being used for giving symbols to elements. Is that clear? So this is how we write the symbols of elements. Now coming towards the formula of compounds and molecules, the first thing that you need to keep in mind is that usually whenever we are writing formula of compound, we usually write the name of metals is written. You write the name of metals first. More specifically, positive charges or ions are being written first. Okay, or they are being written first. Okay. For example, let's suppose sodium chloride. Sodium is metal, everyone knows, and chlorine is non-metal, and sodium is also positive charge, chlorine is negative charge. So first, the metal name of the metal comes first when we are writing any chemical formula. So keep in mind that all the metals, they carry positive charge. This is the important thing. All the metals, they carry positive charge, and that's why if there are metals in a compound, we usually write metal first, then non-metals second. It's written after metals. Okay. In the same case, for example, magnesium hydroxide. Okay, magnesium is metal, oxygen and hydrogen is non-metal. It is being written after magnesium. Okay. In the same case, aluminium trichloride. Okay, aluminium trichloride is aluminium is metal, chlorine is non-metal. If there is no metal present inside the compound, what will we use? We will write positive charge, then negative charge. For example, water. Okay, both hydrogen and oxygen, they are non-metals, but hydrogen, most of the time its charge is positive and oxygen is negative. Okay, minus charge. So that's why first water is H, hydrogen, and then oxygen. I cannot write the formula of water like this, OH2. No, it is not correct. First I need to write the positive ion and then the negative ion. Is that clear? In the same case, other formula, for example, H3PO4. Okay, hydrogen is plus, phosphorus, this phosphate, -3 charge. Okay, let's suppose, for example, KMNO4. Okay, now there are two metals, potassium, magnesium, and oxygen. Two metals. So potassium comes first, after that manganate. Manganate is a separate ion having a negative charge, manganate. Potassium is +1. Is that clear? It is a polyatomic ion, also called radical. Okay, in the same way, for example, sulfur trioxide. Here charge of sulfur is plus and oxygen is minus. Sulfur, both sulfur and oxygen, they are non-metals, but still sulfur, here charge of sulfur is plus charge and oxygen is minus. Is that clear? This is one rule of writing formula, that first we need to write the positive charge and then followed by the negative charge. In the same case, the second rule for writing the formula is that we have to what we need to do. The second rule is that sometimes we also use the words, the prefix, like mono, di, tri, tetra, or penta. These words are also being used in naming compounds. Okay, so these words are also being used in naming compounds. Okay, mono means 1, di means 2, tri 3, tetra 4, penta 5. Let's suppose, for example, this is carbon monoxide. Carbon monoxide. Okay, then carbon dioxide. Okay, carbon is positive and oxygen is negative. Then sulfur trioxide. Sulfur trioxide. Okay, then for example, carbon tetrachloride. Carbon tetrachloride. Okay, penta. How do we use penta? For example, phosphorus pentaoxide. Okay, phosphorus pentaoxide. Okay, so this is how we can name the compounds. First letter, first element is usually the real name of the element. Okay, for example, here carbon, first element is carbon, we will write it as it is, that is carbon. Okay, the second element, change is being brought in the second atom. Okay, like monoxide, oxide, okay, chloride, oxide. Okay, so how many oxygen? 2, 1 oxygen, monoxide. Oxide means oxygen, means that 1 oxygen is present over here. Dioxide, carbon dioxide, sulfur trioxide. Okay, 3 oxygen is present. First name is written as it is, name of the element itself, and the second atom, which have the second element, consists of 3 atoms of oxygen, trioxide. The same way, tetrachloroxide, carbon, tetra 4 means that this element consists of 1 carbon and 4 atoms of chlorine. The same way, this P2O5, 2 phosphorus and 5 oxygen. So phosphorus pentoxide. Is that clear? So this is how we can name and we can write the formula of compounds. Okay. The third rule that you need to keep in mind is that name of oxide. What is oxide? Okay, keep in mind that oxide is when oxygen combines with another element. Okay, for example, carbon monoxide, carbon dioxide, sulfur trioxide, okay, phosphorus pentaoxide. Okay, you can see two elements, one carbon, one oxygen, one carbon, two oxygen, dioxide, one sulfur, three oxygen, trioxide, sulfur tri, two phosphorus, five oxygen, pentaoxide. What if third element is present? Okay, if two elements are present, if there are three elements, okay, three elements, if the compound have three elements, and the third element is oxygen, then we will not write oxide, we will not use oxide word, we will use ate. We will use the suffix ate. Suppose, like for example, sodium sulfate, Na2SO4. Here you can see three elements are present. One is sodium, two atoms of sodium, one atom of sulfur, and four atoms of oxygen. Means three different type of elements are present. So we do not use oxide, we will use ate. That is sodium sulfate. Is that clear? For example, KMnO4. Okay, three type of elements are present: potassium, manganese, and oxygen. Three type of element. Okay, one atom of potassium, one atom of manganese, four atoms of oxygen is present. So we will use the word potassium per manganate. First element is written as the same, followed by permanganate. 8 means that in this compound three elements are present and the third one is oxygen. That is why we are using 8. Okay, second example, for example, let's give another example. Sodium, potassium sulfate, potassium carbonate, or we can say sodium phosphate. Okay, sodium phosphate. Here three atoms of sodium, one atom of phosphorus element, and four atom of oxygen is present. Three type of. So we will write the name as sodium phosphate, phosphorus phosphate. Is that clear? So 8 means that in this compound three elements are present and the third element is oxygen. Okay, number of atoms, it may differ. Is that clear? So this is how we use the terminology 8. We add the word at, we add the suffix at in this type of compounds. Is that clear? The fifth point. The fifth point is that what is hydroxide? Okay, hydroxide means that combination of oxygen and hydrogen. This is called hydroxide. Okay, for example, hydro means hydrogen, oxide, oxygen. Okay, for example, potassium hydroxide. Okay, potassium hydroxide. Is that clear? Sodium hydroxide. Sodium hydroxide. Is that clear? Suppose magnesium hydroxide, OH twice, MgOH twice. This is called magnesium hydroxide. Okay, this is how you can write the formula and name it as it was there. Okay, then aluminium trihydroxide, AlOH thrice. Okay, so you can name the compound as aluminium hydroxide, or you can write the name as aluminium, more specifically trihydroxide. Is that clear? So this is how you can also name the compound. according to the number of atoms. So this is about hydroxide. Keep in mind that all these hydroxide, these are called alkalis. Okay, we will study this in detail later on, but keep in mind that what are alkalis? Alkali is a compound. Alkalis are those compounds that can neutralize an acid. Okay, the compounds that can neutralize an acid, this is called alkali, and we will study this later on in detail. But keep in mind that those compounds that have OH, these are alkalis. Okay, inorganic compounds. The sixth point that you need to keep in mind is about ide. Okay, ide. Some compounds have ide at their end, add ide as a suffix. For example, sodium chloride. Okay, first word is not change. We will just bring change in the second element. Sodium chlorine. We will not write as chlorine. We will write them as chloride. Okay, then magnesium chloride. Okay, magnesium, first element, name of the first element is not being changed. We brought change in the name of the second element, chloride. Okay, so for example, aluminium bromide. Okay, bromide. Aluminium bromide. Ide is being this ide is being used as a suffix at the name at the end of the compounds. And keep in mind that this chlorine, fluorine, chlorine, bromine, iodine, this group is called 7A group in your periodic table. Inshallah, we will also study it later on. But when the first element is a metal, like for example sodium, and the second element is any element from the 7th group of the periodic table, just suppose might be fluorine or chlorine or whatever, we will usually add the suffix ide. Is that clear? So sodium fluoride, sodium chloride, sodium bromide, sodium iodide. Okay, the same way, this is how you can write the formula and name it as it is. So the other important thing about is that there are some special names are also being given, special or specific names are also being given to compounds. For example, H2O, normally it is known as water. Okay, we cannot call it as hydroxide. We cannot call it hydroxide, it is water. Okay, so let's suppose for example CH4, this is called methane. Okay, then for example HNO3, okay, it is nitric acid. Sometimes names are also being given to compounds. Is that clear? Like for example, this is how you need to memorize these names, okay, of compounds. Like for example, sulfuric acid, H2SO4, sulfuric acid, which is also the king of acids. Okay, king of acids is sulfuric acid. Okay, sulfuric acid, H2SO4. So in other examples, like for example, let's suppose like slacked lime, calcium oxide, this is called quicklime. Okay, calcium oxide, another name is quicklime. Okay, so this is how some special names are also being given to some very known type of compounds. They are being used, they are very popular because they are being used a lot in industries, and that's why they are being given some special names. So this is how today's lecture, I hope that you've understood, related to the formulas and related to the symbols of elements.